My name is John Maris. I'm the president of Marinvent Corporation. We were incorporated in 1983 for the purposes of flight test and certification. Our main job is to reduce risk of complex flight test programs. In order to achieve that, we operate one of the most advanced flight research aircraft in the world. It's a Piaggio Avanti, and we've replaced the cockpit of this aircraft with the Epic CDSR system. And that enables us to do flight testing and risk reduction that would be otherwise impossible without this aircraft. Our customer base ranges from NASA, for example. We teach test pilot schools and flight test personnel how to do their job. Governments, we've done a lot of work for the New Zealand government. We've actually even done work with the Russian government to help them in these areas. And a number of avionics firms and independents that need flight testing that would exceed their own capabilities to test and evaluate their own equipment. Our Avanti is designed to house experimental and research avionics as they get developed. We need tremendous flexibility in our avionics. We need to be able to handle almost any kind of interface, display any kind of data. Could be video data, could be ARINC 429 data. So we need the most flexible possible avionics system. Of course, the baseline avionics in the aircraft is not designed to talk to strange systems, such as other flight management systems. Epic CDSR gives us that flexibility. It has the interfaces we require and the computing power and the display capability to do the things that we require. One example is the upcoming ACAS-X. We are heavily involved in ADS-B and TCAS development, and ACAS-X would be the next generation of such work. And our aircraft is ideally suited because it is already equipped with the most advanced levels of ADS-B and TCAS in the industry, plus all of the experimental equipment required to take the data, record the data, play back the data. So ACAS-X is just one example of an ideal program for this aircraft to be employed. One of the capabilities of our aircraft is to perform as an unmanned aerial vehicle surrogate, an optionally piloted vehicle. And ADS-B is one of the ingredients for such an operation. The other one is broadband. We have to be able to simulate satellite links to the aircraft both ways. And the Aspire system was the natural interface between the aircraft, the satellite, and the unmanned vehicle capability we're trying to demonstrate. We've got a long-standing relationship with Honeywell, and we're very well treated by the support staff. And our needs go far beyond what a typical customer would require. We involve technical personnel, marketing personnel, sales personnel, support personnel, with very difficult problems that have to be solved. This is not a production aircraft that does routine A to B flights. And the support we've received has been extremely strong. And whenever we've had technical questions, the right people have been there to help us answer them. And the system itself has been able to support our requirements very well. So it has been a very good working relationship with ourselves and Honeywell.